Hello students, and welcome again to my channel. My name is Mr. Meshak Ngigi, and welcome to eMath with Meshak Ngigi. So kindly today we are going to be looking at ordinary differential equation, and in these types of equation, we're going to be checking when you have functions which are when you have functions on the right hand side. Okay, when you have functions on the right hand side, how do you solve the equation? So remember, we are doing we are doing ordinary differential equations, ODE, still on ODE, that you're doing using the what? The D operator, the D operator method. So in the previous videos, the three videos that we checked, we looked at functions where you don't have a function on the other side, ordinary differential equations when you don't have functions on the right hand side. Now, for functions that you have, for a differential equation where you have functions on the other side, we just write it in a very simple way. The function are the general solutions. The general solutions are written in the form y equals to CF plus PI. Okay, let me write this correctly. So it is written in the form CF plus PI. So what is CF? CF is always what we call the complementary equation, and PI is what we call the partial integral. In short form, we always write it in terms of what? U equals y equals to u plus v, where the u part is the complementary function, then pi is the partial integral. So u plus v is the simplest way to just put it, okay? Now, so we shall be solving two parts of this particular equation. We have the first part where we solve whatever we have been solving in the previous videos. That is the auxiliary part. Okay, yes, what we used to call now the auxiliary part is what we call now the complementary function. Then we solve again the partial integral part altogether. Yes, so this one is a bit okay, not lengthy, but yeah, it has an extra steps ahead of them. Okay, yes. Now we start with the first. So remember, we have different functions. So we're going to start with linear functions, or linear, or you can just say polynomial functions, okay, or algebraic functions. Either we have constants, we have exponential functions, we have trigonometric functions, right, together. So let's start with the obvious one. Let's start with the constant one. So example. So now let's check an example here. So in this one, we're going to be looking just for the general solutions. Okay. Yes. And now, so we have solved the differential equation. Solve the differential equation. Solve the differential equation. So the differential equation b squared y over bx squared, okay, plus dy dx, then minus 2y equals to what? Equals to 4. So you can see now there's a number on this other side. Okay, there's a constant, and that constant is 4. So solution, how do you solve this? So solution. Now we write it still in the operator form. Right together? Yes, we now solve it using the D operator method. Okay, so we shall have it as D squared and so we shall have it as D squared, then plus D minus 2, then you have Y. Now here in our case now, okay, we shall just have it as equals to 4. Okay, yes. Then we substitute m for d. So we substitute m for d to solve. Now in this part, we're going to be solving now for the u part. All right, together. So this one will be m squared plus m minus 2 equals to what? Equals to 0. Okay, so the brackets are not a must. Now, so find two numbers. When you multiply, you get -2. When you add, you get 1. Okay, two numbers, when you multiply, you get -2. And when you add, you get 1. Definitely that will be 2 and -1. Okay, so therefore we shall have +2 and -1. Okay, yes, in terms of factors. So we just put this in terms of the factors. And what will be the roots here? So our m, so it is either m plus 2 equals to 0, m will give you -2, or m minus 1 equals to 0. So m gives you +1. So what do we say about this? They are real and what? And different. Okay, they are real and different. So what will be the general equation? Now remember, here it is not y, it is u. Okay, and remember, for general equation is given by E alpha x plus beta plus b beta x, where alpha and beta are just your values of m. Okay, so your u part will be a exponent -2x plus b exponent 1x, which is just what? It's just bx. So that is the general solution for the u part. Now, we now come to solve for the v part. So again, rewrite this. So we shall have d squared plus d minus 2, then v equals to 4. But now your v is a what? Your v is a constant. Okay, so you replace now your y with a v. Right, together. But v is a constant. So what happens when you're doing this type of function is you have to know what your v represents. Does it represent a function? Yes, a particular function. And what is that function? So if it is a constant, we say we replace it with k, generally. All right, together. So you can use c. C is also a constant. You can use a c, but in this case, we shall use k. If it is a quadratic equation, then you say our v is a quadratic equation. What is the general way of representing a quadratic equation? Ax squared plus bx plus c. Right, together. If your nini is an exponential, what is the way of representing an exponential? Right, together, and so on and so forth. So there's a table of all these functions, but we shall be checking one by one. We shall be checking them one at a go. Right, together. So we are starting with our function being a constant. So our v now here is k, will be represented by k to show that it is a constant. So you just replace your v with k. So it is d squared plus d minus 2. Then you put what here? K equals to 4. Now open this bracket with a k. So it is d squared, not 2. So this one is d squared, put into bracket k, plus d into bracket k, minus 2k equals to 4. Now, what does this mean? This means you find the second derivative of this function, find the first derivative of this function, and this is just 2k. Together. Now, when you differentiate a constant once, it is a constant. What do you get? 0. So even when you differentiate a constant twice, it still gives you what? It still gives you 0. Right, together. So that is what we shall be doing. Differentiate that function v once, twice. Then replace the outcome in the whole equation. So now my derivative of a constant twice is 0. Derivative of a constant once is 0. So replace them here. So here I'll have 0 plus 0 minus 2k equals to 4. So therefore, what do I have on this side? Minus 2k equals to 4 divided by negative 2 divided by negative 2. So therefore, your k value is negative 2. Right together. So this outcome is what we shall be having as our v. So therefore, our v part is negative 2. Right together. So that is the outcome. So the outcome here now gives you your v. So your v therefore equals to negative 2. So therefore, your general function is y equals to u plus v. So y equals to, so y will be given by, so your y will be given by, where is your function? We have our u here, which is a exponent negative 2x plus b exponent x, then plus v. What is our v? Negative 2. And that one is your general solution. Right together. So the general one. So that is the general solution. Now, if you wanted to get a particular solution, it is the same thing that you do. For instance, you get your value when let me just find any value that I can use to get. So let's say, for instance, when, let me add my own limits here. When x is 0, y equals to, let's say, 4, dy dx equals to 9. Yes, I can use that. So if I want to get now the particular solution, very simple. So again, x is 0, y is 4. So I replace it here. I start with the first two. Okay. So my 4, I have 4 here equals to a exponent. This one will be 0 plus b exponent. This one will be 0. Then I have minus 2. Right together? Yes. So I know this one will be 4 equals to, here anything to power 0 is 1. So I'll just remain with a plus b minus 2. Take 2 on this other side. So it gives you 6 equals to a plus b. You see that? Yes. Now, then you come and get the second derivative. My function, so I have that. So let me have it. Let me add a page there. So I have my function as y, sorry. So I have my function y equals to a 2x plus b exponent x minus 2. Then I get dy dx right together. So I drop the power. So I'll have negative 2a exponent negative 2x. I drop the constant. The constant here is 1. So it'll just be b. Nothing changes there. X. When I differentiate a constant, I get what? 0. So there's no value there. So now my value here is 9 equals to negative 2a exponent 0 plus b exponent 0. Remember, now we are replacing x equals to 0 and dy dx equals to 9 together. So dy dx into e9 upper. Then we have these parts. So negative 2 is on to power 0 because x is 0. Okay. And anything to power 0 is just what? Anything to power 0 is just 1. So 9 equals to negative 2. So equals to negative 2a plus b. I can call this one equation 2. So remember we had gotten equation 1, 6 equals to a plus b. So equation 1. So can name this one 1. So now you solve the two of them. So 6 equals to a plus b. You have 9 equals to negative 2a plus b. Elimination method, subtract. So I want us to get the value of b. Okay, the value of a. So it is easier to eliminate b. So b minus that one gives you that. So a minus 2a gives you 3a. Is it? Equals to 6 minus 9 gives you negative 3. So divide by 3, divide by 3. So your a gives you negative 1. Is that true? Yes, because this one and that one goes by 3 by 3, then by 3, 1 by 3, 1, so we get -1. So if A is -1, you can just replace in equation 1. You can just say replace A in 1. So we have 6 equals to -1 plus B. Take -1 to this side. 7 equals to B. So your value of A and B are gotten. So therefore, your particular solution in this case will be given by, so particular. Okay. And particular is referring to particular solution will be given by y equals to A is -1. So it is negative exponent -2x plus, what is our B? 7 exponent x, then -2. That will be your particular solution. So whatever we did in the previous questions, especially when it comes to getting particular solutions, is not any different. Right together. So the only contrasting part or the only addition part is now the fact that you have a function on the right hand side. So you have to find the outcome of the function on the right hand side. Right together. Good. Now let's check a second example. So I'll not drop that, let that remain. Just add another page. Sorry. So example 2. So the first one we checked when the right hand side is out is a constant. Right together. Now let's check the second, and the second one we'll check it when now the function is a linear equation. Okay. So again we'll have an example. 2d squared y. Oh, sorry. So it is 2 d squared y dx squared minus 11 dy dx plus 12y equals to 3x minus 2. So this one is when this other side is a linear equation. And how do you know it is a linear? The equation of a line is written as y equals to mx plus c. Mx plus c. Is this familiar? Yes. So solution. Again, we use the d operator method. So in d operator, you shall have 2d squared minus 11d plus 12 into bracket y equals to now the function on this other side. Okay. So again, replace m for d. Is it? So we have 2m squared minus 11m plus 12 equals to 0. This one you're solving for the u part, or else we call it the auxiliary part. But in this type of function, we call it the complementary part, the u part. Then again, find two numbers which when you multiply, you get 24, because it is AC, so it should be 24. And when you add, you get 11. Negative 11, sorry. Yes, two numbers when you add, you get 24, and when, you multiply, you get 12, 24, sorry, and when you add, you get negative 11. So we say you always use the multiplication part. So our multiple part is 24. So how many parts can you get 24? You can get 24 by multiplying 12 times 2. You can also get 8 times 3. You can also get 6 times 4. So again, check these numbers. Which of these numbers can give you what? Can give you 11 when you add. This one cannot give us 11, cannot give us 11. This one can give us 11. All together. So we'll have 8 and what? We just have 8 and we'll have 8 and 3. So both of them should be negative, so that when you multiply, it gives you positive. Okay. Yes. So I hope you get that. So we have 8 and 3. So, but remember, since our a is not 0, we cannot just write our value m8 and m3 now. So we split them into 2. Okay. So we shall have 2m squared minus 8m minus 3m plus 12 equals to 0. Okay. So factor out what is common. We have 2 and we have m appearing there. So we have m, then you subtract what? Subtract 4. Okay. What is common here? We have 3. Yeah? So 3. You have again m minus 4. Remember, this part and this part should be the same, because if you open this bracket, it gives you a positive. So you have 2m minus 3, and you have m minus 4 equals to 0. So it is either 2m minus 3 equals to 0. So m will be given by 3 over 2. Again, this one, m will be given by, so it is m minus 4 equals to 0. So m equals to 4. The roots are the what? Real again and different. I hope we are together. Yes, they are real and different. So if they are real and different, how do you write your u? You will be given by a exponent. What is your first value? 3 over 2 x plus b. What is your second value? 4x. And those are your two outcomes for the u value. Right together. So that is our u generally. Then you come to the second part of this part. So we have, now we solve for u. That is the partial integral part. So we shall have 2d squared minus 11d, that does not change, plus 12. Then here we write what? V equals to 3x minus 2. So again, how do you write equations of a line? We say, now inakuanga y equals to mx plus c. Okay, but we shall change our values here. We now use a and b. Okay, together. Yes. So here v part will be ax plus b. I hope we're together. All right. Now you just replace it here. So we have again 2d squared minus, not plus, minus 11d plus 12 into bracket ax plus b, okay, equals to 3x minus 2. Then these, to open this bracket, it is 2d squared for the first part, ax plus b, minus 11d, is that d? So minus 11d ax plus b, then plus 12 ax plus b equals to 3x, sorry, 3x minus 2. 3x minus 2. So you can see this part just takes part in every part of the whatever you have inside there. So this part and this part, this part and this part, this part and this part, then equals to the other side. Now, remember, we are doing first and second derivatives. So we are interested with the derivatives first. So we check the first derivative of ax plus b. So remember, we are differentiating with respect to x. So b does not have an x. So you only differentiate this part. And when you differentiate ax, you remain with what? The x goes, you remain with a. Are we together? Now, let's come to the second part, the second derivative of ax plus b. So remember, you had already differentiated once. So differentiate it again. But a is a what? A is a constant. When you differentiate a constant, what do you get? 0. We together? Very good. Now, so that means where we have the second derivative here, the answer, so we'll have, let me just rewrite it, d squared, so we'll have 0 here. Then minus 11, what do we have at the first derivative? A. Then plus 12ax plus b equals to 3x minus 2. So the whole of this is 0. So you remain with what? Negative 11a. We can open this bracket now. Plus 12ax. Then plus 12b equals to 3x minus 2. All right. Now, let's start with the one that has an x so that it can be the same with the other side. So ax minus 11a plus 12b equals to 3x minus 2. Now, we need to get the value. We need to compare. We need to compare the value of a on the value that has an x on this side. Let me note something here so that we really get it. The value that has an x on this side and the value that has an x on this side, because we're saying whatever is on this side should be the same as whatever we have on the other side. So anything that has an x here should be the same that anything that has an x. Anything that is a constant here should be the same as the constant on the other side. So I'll use that as a pen. So what has an x? 12ax, and here we have 3. So we compare 12a, okay, with what? 3. The x and the x on the other side. So 12a, so you divide by 12, you divide by 12. So your a by 3, 1 by 3, 1, 4. So it gives you 1 over 4. And that is your value of a. Now, come to the second part. Let me just draw a line there. Compare the constant. Remember, the easy is not any constant. This one is a constant, this one is a constant, and there's a constant on this side. So therefore, negative 11a plus 12b should be the same as negative 2. Now together. So therefore then, negative 11, what is our value of a? We had it 1 over 4 plus 12b equals to negative 2. So we have negative 11 over 4 plus 12b equals to negative 2. Take this to the other side. So negative 11a plus 12b equals to negative 2. So continue. Excuse me. We have negative 11 over 4 plus 12b equals to negative. Excuse me. So take this to this other side. So you have 12b equals to negative 2 plus 11 over 4. And what does that give us? So negative 2, sorry, plus 11 over 4. That gives us 3 over 4. Okay, so 12b equals to 3 over 4. And we want to get b. So multiply by what? 1 over 12 this side by 1 over 12. So your b value will be by 3, 1, by 3, 4. So it is 1 over what? 1 over 16. So therefore your v part, which was generally represented by ax plus b. What is your value of a? So your v will be 1 over 4x plus 1 over 16. So what will be your, so that will be your v. So therefore our general solution y will be given by a exponent. Here we had what? 3 over 2. So value 3 over 2x and b. So 3 over 2x plus b 4x. Then this one is your u. Okay, remember it is y equals to u plus v. Then our v is this. So plus 1 over 4x plus 1 over 16. And that is your general solution. Interesting? Yes. So that is just the difference between the first and the second. So here you're getting your u part and you're getting your v part by the end of the day. Okay, so you have that and you have that. All right. Now, that is the second example. All right. Remember, you can also get another one which has a quadratic equation. And how do you write quadratic equation? So if you're having a quadratic equation, I leave that to you for you to try it out. If you're having a quadratic equation, the v part here, where are we here? Let me use this. So the v part, this part here, will be given by what? A x squared plus bx plus c. Together, x squared plus bx plus c. That is how you write your quadratic equation. And you replace them here. So the function, general function, will be put here. Here. Then you find the first derivative, the second derivative. Then expand, open the brackets and all that. Then compare whatever you shall have here with whatever you shall have on this other side. Right, together, for you to find the value of A, B, and C. So in this case, you'll be finding the value of A, the value of B, and the value of what? And the value of C. All together. Yes. So you have that. So that is when you shall be having now, when you shall be having a quadratic part. Now, let's check. So those are, that is polynomial end and constant. Okay. Now, so let's check one. Let's go to exponential. And here we're going to be checking now the particular solution, because I believe in this one we have limits. So example. So example 3. So example 3, the function is given by, remember, again, the function does not really, it doesn't have to be du dx, dy dx, sorry. It can be dy dt, it can be dq dt. But the point is, it remains to be the first and the second derivative by the end of the day, right, together. Now, so let's check the another one. So we have d squared y dx squared minus 2 dy dx, then plus y equals to 3 exponent of 4x. Interesting. Now this one is an exponential function. So therefore, when x equals to 0, y equals to 2 over 3 negative. Now we just negative 2 over 3. Then dy dx equals 2, 4 and 1 over 3. All right. The fraction should not scare you. Okay. Yes, the fraction should not scare you at all. So again, solution. So solution. So remember, in this question here, if you are, this one is a general equation, okay? This one is general. So for particular solutions given limits such as this, you just go on, you continue, okay? And I believe when you are having, when you're getting the particular solutions, at the end of the day, also the marks are good, eh? Yes. Now, so let's write this in d operator. Remember, we're still on the d operator, so we shall have d squared minus 2d plus 1. So that should be 1, not 2y. So in d operator form, plus 1, so we have 1 here, then we have our y outside, should be given by 3 exponent of 4 for x, right? Then we go to the next step, we say replace or substitute m for d. Now we have m squared minus 2m plus 1 equals to 0. So we are solving for the u part again. Two numbers, you multiply to get 1, you add to get negative 2. Definitely that is negative 1 and negative 1. Right? Because negative 1 and negative 1 gives you negative 2. Negative 1 times negative 1 gives you 1. Okay? So m negative 1, m negative 1 equals to 0. All right? So therefore, what will be your value of m? And you can already see what this one is. So your m value can be m equals to minus 1 equals to 0. So m equals to 1. Also in this other one, it's still the same. So m equals to 1. So what do we say about this? This, your roots are real but repeated. They are real and same. Okay, I'll just say real and repeated right together. And how do you write when you have function, when your values are being repeated? Very simple. It is written by u generally. I'll just write the general e x plus b exponent alpha x, where alpha is the repeated value. Okay, so in our case here, what will we have? U equals to ax plus b exponent 1x. So it is just x. That is our u part. Are we together? Good. Now let's go to the second part, and that is this part here. Okay. So how do you write how do you write v? This one is an exponent, yeah? Yes, it is an exponent value. How do you write the function generally? So basically, we shall write the function in the form. So the exponent, because we have the exponent itself, so we shall just rewrite the function. So it is written by our v. Let me just put it in this form. V, we have a constant here. And how do you write a constant? K. Then the function itself is just written the same way it is. K for the constant, exponent of 4x. Right together? Yes. And that is it. So now from there, you can now rewrite this part, then v. So we shall have d squared minus 2d plus 1 into bracket v equals to 3 exponent for x. So remember here the part here is to determine the value of k. So it rewrites it again. It is d squared minus 2d plus 1. So function is d squared. So k exponent. Now, why do you put the exponent the same way it is? It's because so that you can compare on the other side. Remember, you always, by the end of the day, you compare what you have on the left hand side and what you have on the right hand side. Right together. Yes. So now you'll have d squared into bracket k exponent 4x minus 2d k exponent 4x, then plus 1 times that, just k exponent 4x equals to 3 exponent 4x. So we find the first derivative of k exponent 4x, second derivative of k exponent 4x. So first derivative, what do we get? Remember, you drop the what? Drop the constant. So it is 4k exponent 4x. You always drop the constant. So when you differentiate it again, drop again the constant. So it gives you 16k exponent 4x. Right together? Yes. So we have that. So and then you replace them in the function. So you have the first derivative and the second. So we have this part here is this. So it will be 16k exponent 4x minus 2. This part is this. So 4 exponent 4x, then plus k exponent 4x equals to 3 exponent 4x. Then you can open the bracket. So you have 16k exponent 4x minus 8 exponent 4x plus k exponent 4x equals to 3 exponent 4x. So all these are the same. So just add and subtract them. So 16 minus 8 plus 1, or 16 plus 1 minus 8 gives you, is it 9? Yes, it gives you 9 by the end of this. So 9k exponent for x should be the same as 3 exponent for x. So compare this part and this part together. So 9k equals to 3. So divide by 9, divide by 9. K equals to what? 1 over k equals to 1 over 3. And therefore, your y function will be given by ax plus b exponent of x plus, remember our v was k exponent for x, right, together. So now it is 1 over 3 exponent for x. And that is your function by the end of the day, right, together, because y, we said, just a reminder, y is given by u plus v. What did you get our u to be? Our u is here. Where is our u, our u, our u, our u? Is here. Okay, that is our u. Then we have our v here. Sorry. Then we have our v. So our v equals to 1 over 3 exponent for x, because our k is 1 over 3. So this one is our v. So u plus v, our u is the whole of this. Our v is that part. So that is our general. So this one is our general. One is our general solution. Now we want particular solution. Okay. So particular solution. So for particular solution, shall have so we have our y equals to ax plus b, then we have exponent of x plus 1 over 3 exponent of x. So what was our limit? 0, negative 2 over 3. So when x is 0, y equals to negative 2 over 3 dy dx equals to 4 and 1 over 3. So we just input our limits and see what we have as our outcome. So shall have now, okay, start with the first one. So it is y, okay, we have the value of y, sorry. So our y is negative 2 over 3 equals to our x is 0, so a times 0 plus b, a exponent power 0 plus a third exponent, 4 times 0 is 0. So you'll have negative 2 over 3 equals to b. Remember, this one will be 0, this one will be b, this one will be 1. So you'll have what? You'll have b plus 1 over 3. Take 1 over 3 to the other side. Negative 2 over 3 minus 1 over 3. So it is negative 3 over 3, which is negative 1. Is it? Yes. So taking this to this side, we are saying, so basically we're saying your b will be negative 1, because when you add this fraction, it gives you negative 1. So not this. So we already have our b. Now we need to determine our a. Okay, we need to determine our a value. Now we differentiate this function with respect to x. Now, not something about the first part of this function of y. This part here. This first part here, the first part, differentiating this one has no issue. But the first part, this part here, that part has two functions. Okay? It has the linear function and it has the exponential function. So you're multiplying two functions. So which rule do you use? On this first part, it will be the product rule, okay? So we let our u, so let u to be ax plus b together. V will be exponent of x. u prime, when you differentiate that one, you're only differentiating where you have an x. Okay, yes, so you have a, then v prime will be exponent of x. It doesn't change because your variable, your constant here is 1. So when you drop 1, still remains the same. Okay, then now you input, now this part, you now input it in the form y equals to u, okay, vu plus uv. Either of them is okay, since you are just adding vu prime plus uv prime. So remember, this is for this part. This part will just drop 4, so there's no issue. So you're saying our dy dx here will be given by, so for this first part, we use the formula. So v, our v is exponent of x, u prime is a, okay, then plus u ax plus b v prime. So for this part, this is the derivative. Then plus, now differentiate this part. You drop 4. So it gives you 4 over 3 exponent of 4 for x. Right together? Right. So therefore, you can now replace, you can choose to replace the values. So it is this and this, these two. So let me change my pen. And we shall have, so dy dx is 4 over 3, 4, 1 over 3. So this one is 12, 13 over 3. So you have, this one is 13 over 3 equals to, this one is a exponent 0, just interchange, but x is 0, plus a 0 plus b, again, e 0 plus 4 over 3 exponent 0. Right together. So just be careful when you're evaluating this part, equals to, so a e to power 0 is 1, so times a gives you a, plus this one is 0 plus b, so plus b, because this one is 1. Right together. This one is for this part. This one is 0 plus b, so you have b because this one is 1. Then plus this one is 4 over 3 over 3. But you have your value of b. B is negative 1. So you'll have, so let me bring all of them here on this other side, then I evaluate. So you have 13 over 3. This one is minus 1, okay? So I bring it to this side, it becomes plus 1. This one I bring it to this side, it becomes minus 4 over 3. That should give you a value of a. So let's evaluate that. That is 13 over 3 plus 1, then minus 4 over 3. And that should give us 4. So your a value equals to, 4. Let me write it here so that you can have some space of writing the general function. So a value equals to 4. Let me put it that way. So therefore, what is your general equation by the end of the day? Where was our general equation? We had it here. General is here. General is here. So therefore, you can now write and say this one will be given by, so particular, y equals to, our a value is 4, so it is 4x plus, what is our b? Our b is negative 1, so this one changes to become negative 1. So we have negative 1 into bracket exponent of x plus 1 over 3 exponent of 4x, and that is your outcome by the end of the day. Are you together? And that is it. So yes, that is your function by the end of the day. So you can really see how all these functions are coming together. We're applying the knowledge that we have from auxiliary equations, okay? Now we solve the complementary part that we're just saying in short form, it is y equals to u plus v. So you get the u part, which is gotten from the auxiliary formula that we used before, then get the v part by comparing the general representation of a function and differentiating them, getting the general solution. Then from there, input your limits. After inputting your limits, you get your outcome by the end of the day. So thank you. Now we meet in the next lesson where we shall check, I think, the last part, which is a trigonometric part, for the sine and the cosine part. And that is how generally you shall be solving any ordinary differential equation. So thank you and see you in the next lesson.